Before we start, I would like you to hit that red subscribe button so that you never miss out on any of our videos. Hey guys, what's up? Welcome back to Massive Phenomenon. 6. The Cosmic Microwave Background Cold Spot. Cosmic Microwave Background, or CMB, is a radiation from the Big Bang. It covers the universe almost uniformly. There are, however, some small abnormalities. These act as cosmic breadcrumbs of sorts that lead back to the universe's infancy. But there is a patch known as the cold spot that's not playing by the rules. Its sheer size coupled with a slightly lower temperature is enough to cause cosmologists to ask why. The leading theory was the CMB might have crossed the equivalent of an enormous cosmic desert called a supervoid. These barren regions can zap energy from light crossing them due to their expansion over time. It's kind of like a cosmic toll booth, causing the light to cool and redshift more than average. But recent research has thrown a spanner in the works. This study suggests that known supervoids, even unseen ones, can't account for the old cold spot's temperature depth or imposing size. Will we ever know where these cold spots come from? Number 5. Wow Signal Origins. On August 15, 1977, astronomer Jerry Emmon detected a powerful, brief, and unique radio signal using Ohio State University's Big Ear Radio Telescope, a signal that has never been repeated or detected again. It was tightly constrained to a narrow band of radio frequency, something nature doesn't usually do. It also wasn't a broadcast from Earth or a passing satellite. It was something else, something special, and it lasted 72 seconds. Many, including John Cross, the director of Big Ear, have suggested that the WOW signal could be a potential sign of extraterrestrial intelligence, as the signal's characteristics were so unlike what we typically observe. The hunt for its origins has continued ever since. Astronomers conducted a focused search for a sun-like star that was considered a plausible source for the signal. It turned out to not fit the criteria, and the mystery is no closer to being solved. Number 4. Baryon asymmetry. Nothing should exist. A fraction of a second after the Big Bang, the universe was brimming with participle antiparticle pairs that, upon touching, obliterated each other, leaving nothing but pure energy behind. Makes sense so far, but here's the problem. If this perfect balance was the norm, we should have a universe full of energy and nothing else. Yet here we are, surrounded by a universe filled with matter. This means particles survived when they shouldn't have, creating everything we see today. The preferential survival of matter over antimatter is what we call the baryon asymmetry problem. To try and explain this, scientists hope to use CERN's Large Hadron Collider to study particles. One explanation that is being explored is that the laws of physics might not have been the laws of physics, and at the moment of the Big Bang, scientists have made some observations through processes like charge parity violation, but nothing that clearly explains everything we know. Number 3. Supermassive black holes. Black holes are the ultimate conundrum. Think of an object so dense that no light can escape its gravitational pull. Now make it millions to billions of times more massive than our sun. That's a supermassive black hole. How do massive things like this form? We don't actually know for sure. We have some theories, but since these behemoths literally birth galaxies, we aren't certain. The first theory is that, like their smaller stellar mass siblings, supermassive black holes might be formed from the gravitational collapse of a celestial object. In this case, it might be a massive gas cloud in the early stages of galaxy formation, like how a star forms but on a vastly larger scale. Another theory suggests that a regular stellar black hole could eat surrounding material over millions of years, gradually growing in size until it reaches supermassive status. A similar theory is that when a cluster of stellar black holes collide, all their mass coalesces into one supermassive black hole. Whatever the case, most astronomers concur that once formed, these supermassive black holes derive the activity of galaxies. Number 2. The fine-tuning problem. The gist of the fine-tuning problem is that the realization that even slight adjustments to these fundamental laws and constants could lead to a universe where life as we know it can't exist. Imagine tweaking gravity or the strong nuclear force just a smidge. This might mean no stars, no planets, no chemistry, and ultimately no life. Some of these constants, like the cosmological constant influencing the universe's expansion rate, appear suspiciously fine-tuned to an almost unnatural precision. Does this mean the universe was designed for life? Not necessarily. Some scientists propose the multiverse theory as an explanation where our universe is merely one of an infinite number, each with its unique set of laws and constants. We just happen to live in the one where conditions are right for life. Essentially, it challenges us to question our understanding of the universe, its origin, and our place in it, inspiring new hypotheses and driving scientific exploration. Number 1. The axion. Axions are the Houdinis of the particle world. In 1977, physicists noticed an oddity. Certain interactions between particles should have violated CP symmetry, the idea that the laws of physics remain unchanged when a particle is swapped with its anti-particle and inverted, but surprisingly, they didn't. The hypothetical axion emerged as the solution to this conundrum, and they're among the most promising candidates for dark matter. Scientists believe that these low-mass, low-energy axions could have been produced in huge quantities during the Big Bang and could now be filling the universe, explaining some puzzling observations in astrophysics. They are still theoretical, but if scientists are successful in their experiments, we may finally get a lead on the identity of the universe's missing mass content. This brings us to the end of our video. I hope you enjoyed it. Hit like if you did, and don't forget to subscribe to our channel so that you won't miss any of our videos in the future. Also watch the 2 videos that are on your screen because I'm sure you love them. With that, I'll see you in the next video.